Hello everyone, and welcome to our next lesson in sound systems. So in our first lesson, we talked about how to choose the right microphone. We mainly focused on dynamic and condensers. In our second lesson, we talked about how to point them in the right direction. That would be making sure we understand their polar pattern and how that affects the placement of the microphone. And now in this lesson, we're going to talk about how to get the microphone information to whatever sound system or recording device you're planning on using. So here we go. Today, we must get the microphone to another sound source in some way, shape, or form. So this is what we want to know. At our stations at school and what I'm using right now, if we were going to record straight into a computer, then we need what is called an audio interface. And this is a box like you see right here, which should look very familiar to you from class. This is the audio interface. It contains two preamps, and these preamps are located right here and right here, with controls for number 1 being up here and control for number 2 being right here. Okay, the preamp takes that really minute electrical signal that we're getting from the microphone and magnifies it. And how much it's magnified by is what this knob is controlling right here. This is called the gain knob. The gain knob is determining for us how much that little itty bitty signal that we can't really sample very well gets blown up so the computer can see it and analyze it as good as possible. So that's the gain. Gain is not to be confused with volume. Volume is on the output end. Gain is on the input end. You could have a really high gain microphone that was recording really soft sounds like a whisper and it would not be loud, or you could have a really low gain microphone that was recording really loud sounds like screams or gunfire or something like that, and it would not be very loud because the gain would be kept low. So you have to adjust the gain based on what you're recording so that you get a good solid level for sampling by the computer. So this is actually what converts analog audio signal into digital so our computer can store it. Again, these are the preamps right here. These are the gain knobs right here. So this does what we call analog to digital conversion, or A to D conversion. A lot of times on the internet, you'll see that as A/D. This also can do DA conversion, or digital to analog, because it has the ability to push to headphones or speakers, but that's on the outcoming side. And right now we're talking about getting the microphone signal in. So getting the microphone signal in is analog to digital converter. And this hooks up to the computer via USB. And when it's hooked in USB, then we're getting that nice solid signal in to sample from. Now, a mixing board is another device that is used in studios. If you've looked in my office at school, you've seen a 32 channel mixing board that is also an audio interface as well. Here, instead of just having 2 channels like we do at each of our stations at school, here we have 32 channels on this board up here, 4 channels on this board right here, and maybe as many as 72 and on in a professional studio size console. So all this does is it combines all the audio signal into one set of stereo signals. So it takes all 72 of those channels and just funnels them right in to be a nice signal that the board can analyze. So this is a lot more often used for live performance. So if you have a drummer on stage and you've got 9 microphones on the drum set and the singer and the band and all that, you might have 32 different inputs coming in, and this funnels it down into 2 outputs so that your speakers get that. They can get rather big and they can get rather expensive. So now we need to know how to connect our microphones like this into the audio interface. And to do that, we're going to use an XLR cable. So XLR stands for X series latch and rubber. So the X series is the way the wiring is done on the inside. You can see right here that there is a latch and these parts are rubber. That's how it got its name, XLR. It was actually originally invented by the Canon camera company, which may seem a little bit on the odd side, but that is what it was done. You can see that there are 3 pins, pin 1, pin 2, and pin 3 down here. This is the male side. This is the female side. I think by the time you're in high school, you probably should understand why those are labeled that way. All microphones are male on the microphone end, so they attach to the female and snap in with this latch to the female end of the cable, and then all preamps are female and they use the male end of the cable. Now this is what we call a balanced signal, and here's why. A microphone is only one audio signal, a mono signal, but it is being sent on both of these pins. So what's the third pin? The third pin is what we call ground. Anytime we're dealing with electricity, we have to have a ground. So this is balanced because we have 2 hots to a ground. We could go into more detail, but understand that balanced is these 2 pins versus the ground pin. Because it's balanced, this is good to up to about 200 feet worth of cable without a major problem. Now, I want to show you. I hope you can see this. This is an XLR cable. Nice and purple. And here's the female end. You can actually connect and combine multiple XLR cables. You'll hear it click. So that's the latch actually engaging. So if you want to hook a microphone up, you line the pins up with the microphone. You get the click. When you get the click, you know you're good, you're set to go, and this end simply slides into your audio interface or your mixing board. Again, this is a balanced cable. It's good for about 200 feet. So that's a long way, and that's how you connect most microphones. Now, a TR cable is often what is used to be for instruments. So this is connecting instruments like guitars. Here is a TR cable. I have one right here. This is the male end of the cable, and you can see the female end here on the screen. There are 2 pins in this cable. Let me show you. There's a pin right here, and then there's a separator. In this case, it's blue. On the computer picture, it's black. And then there's this pin right here. So instead of having 3 pins like this, like you have in a XLR cable, these pins are all part of the one large cylinder that comes up. So here's one pin, and then it's split, and you get to this. So inside there's a wire that's connected to this, and there's a separate wire that connects to this, and this is what keeps them from touching and messing up. So this is a TR cable. Now, because there's only 2 pins, one of them is ground, one of them is the hot signal, and that makes for an unbalanced cable. An unbalanced cable is very susceptible to interference from things like fluorescent light bulbs and different things like that, radio frequencies. It's only good for about 20 feet. So if you're a guitar player and you have a 50-foot guitar cord, you're losing a fair amount of electrical signal because your guitar cord is just too long. So you would need some kind of buffer in that chain to get any more length out of that. So again, that is a TR cable. They come in this 1/4 inch size mostly, but occasionally you'll see one in an 1/8 inch size, but it's pretty infrequent. Let me see where the, okay. Again, female side, male side, unbalanced audio signal, good for about 20 feet. Here is a TRRS cable. Now this looks very similar to what you just saw on the TR cable, but this time, if you'll notice, there are two dividing lines instead of just one. So now we have the tip, the ring, and the shank. So TRS. That is a 3-pin connection. Now that we are in a 3-pin connection, we are now back to a balanced signal. So this is used more for carrying stereo audio signal. You've seen this most often on a pair of headphones. So you have one signal that's leading to your left ear, one signal that's reading to your right ear, and one signal that is the ground signal. Remember, anytime we're using electricity, we need to have a ground, let's go back, a ground signal so that everything is balanced out. Here we go. This is a TRS connection. Now this is the 1/8 inch size. So here we have the tip. It's divided with that black line, the ring divided with the black line, and the shank. You've seen this on your headphones at some point in time, you've noticed. So one is going to your left ear, one is going to your right ear, one is your ground signal. So that is a TRS cable. So this is good for about 100 feet, so much longer without causing major amounts of signal loss. And most of the time, this is for connecting stereo signal transfer or 2-channel signal transfer. So here we go. The TRS versus the TR cable. You can see the tip, the ring, and the sleeve or the shank. Either way you want to think of it, tip, ring, sleeve. And this is just tip and ring. You don't have a separate sleeve connection. Now, some of you may have seen this cable before on your headphones, and it actually is a 4-pin connection. You've got TRRS is what this is called, TRRS. It's divided in 3 places. Now, what else might headphones have in them that would cause this to be necessary? Oh yeah, a microphone. So now you have your left ear, your right ear, your microphone, and your ground signal that leads to all of them. So this cable actually takes care of both outgoing on these 2 pins and incoming on this pin to get that signal transfer. So that would be a TRRS, just in case you've ever seen that. That's side knowledge for you. Like I said, they come in 1/4 inch and 1/8 inch sizes. This is more what we call a consumer grade plug, the 1/8 inch, and this is more like professional grade or studio grade on the 1/4 inch. A lot harder to break the 1/4 inch plug than to break the 1/8 inch plug. Now, once you get the signal into the mixing board, and the signal needs to come out of the mixing board and head to a speaker, that's where this bad boy comes into play, the amplifier. I wish that we were in class so that I could actually have someone hold one of these. This amplifier that you're seeing right here in this picture, double check, what's that? Okay. This amplifier is probably actually about 30 to 40 pounds. There is a lot of stuff happening right here in this box. The goal of this box is to take the slightly more substantial audio signal that has come out of your mixing board and turn it into a massive amount of electricity, and that will push and pull on these huge speakers and magnets. So this is the part that actually plugs into the 120 volt wall jack at your house. So this is what consumes all the power. It takes that really little signal and blows it up into something that's massive. So it's important that you're really careful when you deal with one of these, because you can actually get a pretty nice size shock out of this. Because if you're like driving a subwoofer really hard and you were to be holding that cable, you could actually get shocked as this thing pumped all the electricity in the fashion that the music is traveling. Because of that, they invented this little thing called a Speakon cable adapter. Speakon is really an XLR cable with a safety on it. You can't actually touch any of the metal pins in here. They're all hidden down inside of here. And in order to connect it, you have to push it in and give it about a quarter twist. It's still a 3-pin connection. It's balanced, and all it's they generally come with a little bit better shielding as well. So it's good for maybe 1,000 feet. The push in and the lock keeps people from pulling out and touching it when it's working, and keeps you from getting electrocuted. But that's a Speakon adapter. These are passive speakers. Passive speakers are required when you use an outboard amplifier like the one that was in the picture just a second ago. If you have a box that's just doing the amplification, then you use a passive speaker. This speaker does not need to be plugged into a wall electricity outlet. The amplifier is plugged into the wall electricity. This is just having the Speakon cable run to it. You can see that here we've got a Speakon connection, and these are TRRS connections. So all that goes into the back of this amplifier is just the audio signal. And at that point, because it's coming out of an amplifier, it's strong enough to push these speakers and make the speaker move back and forth and create the audio that you're trying to recreate. Now, there is another option if you want something a little bit smaller, more like for your bedroom or your home studio. These are active or powered speakers. Either term is commonplace, the active or the powered speaker. These do not require an external amplifier because they have an amplifier built in. You can see here, this is the electricity component. It actually has to plug into the wall. The amplifier is inside the speaker, and then you plug your audio signal in here, and that way it's actually drawing electricity, boosting the signal, and moving the speaker on the ohm. The good thing about this is they never put an amplifier in here that doesn't match the speaker that it is built in with. So if you're ever worried that your amplifier will be too strong for your actual speaker, then you might want to go with an active speaker, because you can overpower an amplifier and a passive speaker, and it will cause it to smoke and ruin your speaker. So one thing to consider if you're ever buying a separate amplifier and speaker is make sure the power ratings are matched on the two. But if you're buying active or powered speakers, they've already done that in the company for you. Now, finally, I just want us to talk through this right quick. This is just a basic signal flow for a live sound system. Right here we have a microphone. It's being connected to our soundboard with an XLR cable. Here we have a Telecaster guitar. It's being connected to our soundboard by a TR signal. So all these things are running in to the mixing board. We're controlling our volumes with these knobs. We're controlling the sensitivity or gain with these knobs up here. And our master volume control is over here. So that master volume control is one for left side and one for right side, depending on what the pan is. So if we've got a left and a right signal, then we need 2 cables to get to our amplifier. They could either be XLR or TRRS, depending on what your amplifier requires. Here you control the amount of output that you're sending to your speakers on your amplifier, and you would run a separate cable to your left speaker and a separate cable to your right speaker. So this would be the most basic signal flow diagram for a sound system. So now we've talked about how to pick the right microphone, how to point the microphone in the right direction, and here we've done the plug it into a preamp and run it through your sound system. So I hope you know all the different cables. I hope you know what an amplifier does, why you need it, which type of speakers you would want to buy, how a mixing board would fit into the equation. I hope this all makes sense. I appreciate you watching. Have a great day.